Okay, good morning class. We're busy with probability. The last exercise, before the revision exercise, the last section that we need to have a look at. The homework was exercise. Did we do this question already? Yes. Okay, so that one can be taken out. Exercise 5. And exercise 5 is on page 324. Did we answer none of these questions? Huh? No. Exercise 5 on page 324. So we are told, consider the letters of the word night. If the letters are arranged in any order without repetition, the letters may not be repeated, to form different words. What's the probability that the word formed will? So how do we work out probability? It's a number of possible, the favorable. Your probability is your number of favorable outcomes over number of possible outcomes. Okay. Now if you're looking at the possible outcomes, how many letters do we have here? 1, 2, 3, 4, 5, 6. 6 letters. Letters may not be repeated. So it's simply going to be 6 factorial. Not so. That's your possible outcomes. The condition is, it starts with the letter K, but ends with the letter T. So what are we left with? We are left with NIGH. Not so. So what is the arrangement? How many ways can that be written? 4 factorial ways. Not so. So there's 1 and there's 1. How many repeated letters are there? 0. So 0 factorial is 1. So that is just 4 factorial. So that is 4 factorial. So it says 31 over 30, I think. 4 factorial over 6 factorial. 1 over 30. You all okay with that, people? In B, they want to know starts with the letter N. So you start with the letter N, the possible outcomes is still 6 factorial. Not so. So if it starts with the letter N, we are left with K, I, G, H, T. Not so. There's 1 times. And how many letters are here? 5 factorial over repeated letters? 0 factorial. So it's 5 factorial, which is 1 out of 6. Do you guys understand? Let's look at number 2. Oops, I need space. I don't have to delete this. Number 2. We are told in number 2, consider letters from the word clipboard. The letters are arranged in any order without repetition. Letters may not be repeated to form different words. What's the probability that the word form will? In the first case, start with the letter C and end with letter D. How many letters are here? 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Starts with the letter C and ends with D. Okay. Is there any repeated letters there? No. So they want to know what's the probability. So the probability is going to be number of possible outcomes over, no, number of favorable outcomes over number of possible outcomes. So it starts with C and end with D. We are left with 7 letters, not so. So it's 7 factorial over. How many letters are there in total? 9 factorial. So 9 times 8 is 1 over 72. Is that correct? Just let me know when I'm going wrong. B. Starts with the letter O. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9. So you're starting with the letter O. So I have one option. How many letters are we left with? 8 factorial. Not so. Any repeated letters? No. Identical letters, sorry. No. The 0 factorial, which is simply 8 factorial. So your probability is number of favorable outcomes, which is 8 factorial, over number of possible outcomes, which is 9 factorial, which is 1 over 9. Is that correct? Yes. You look at number 3. Number 3, we are told that the password is formed using 3 letters of the alphabet, excluding letters A, E, I, O, U. They are also known as vowels. And using any 3 digits excluding 0. So how many options do I have in terms of the digits? 9. Okay. Calculate the probability that the password chosen at random. In the first case, 3A. So it's a 6-letter combination. So it's 1, 2, 3, 4, 5, 6. Starts with the letter B and ends with the letter 4. Starts with the letter B and ends with the letter 4. Okay? Password is formed using 3 letters of excluding and using any 3 digits. The numbers and letters can be repeated. So how many options do I have for bit 2? So there's one option here. Not so. For bit 2 is how many options? Huh? How many letters are there in the alphabet? 26. Minus 5. Huh? 21. So how many options do I have here? Huh? 21. Times. How many options do I have here? 9, then 9, then 1. So this is your number of favorable outcomes. Not so. I said we always start with number of possible outcomes. But if I got here, number of favorable outcomes is going to be 21 squared times 9 squared. Number of possible outcomes. Possible outcomes is what? Again, 1, 2, 3, 4, 5, 6. So how many options do I have on the first bit for the possible outcomes? 21 to choose from. Then 21, then 21. How many options do I have here? 9, then 9, then 9. So in other words, it's going to be 21 cubed times 9 cubed. So your probability is going to be number of favorable outcomes, which is 21 squared times 9 squared, over number of possible outcomes, which is 21 cubed times 9 cubed. Okay, that gives us an answer of 1 over 9 times 21 is 9, 189. Is that correct? Right. Any confusion here? I'm going to keep this number of possible outcomes because that will remain for the rest of the calculation. Okay. I'll take this out here. So that is 3A. Look at 3B. Okay, so B has exactly one B. So it's 1, 2, 3, 4, 5, 6. Not so. So if it's one B, the B can lie here. Not so. Or it can lie in the middle. Or it can lie on bit 3, the last bit for the letters. Not so. What's the condition? It must only occur once. So is there any other scenario where that B can lie? No. Can I have double B's? No. Can I have 3 B's? No. Exactly one B, so only one B can be used. Right. This is for the number of favorable outcomes. No? So how many options do I have on bit 2 in the first row? I have 21 to choose from. Can I choose B again? No. So it's 1, eh? That is 1. How many options do I have here? 20. Here? If I chose A here, could I use A again? Yes. Why? Letters can be repeated. Can you see that, people? So how many options do I have here? 20. Yeah? 9. 9, 9. So this is, in other words, 1 times 20 times 20 is 20 squared times 9 cubed. Not so. If I do it here, how many options do I have on bid? 1 in the second row. 20. Then, so this is 1 option. Then, 20. Then, 9, 9, 9. Which is 20 squared times 9 cubed. Not so. Let's look at the next one. How many options do I have here? 20. Then, 20. Then, 1. Then, 9, 9, 9. So that is going to be 20 squared times 9 cubed. So this can be written as 1. As what? 20 squared plus 9 cubed plus 20 squared plus 9 cubed plus 20 squared times 9 cubed can be written as 3 times 20 squared times 9 cubed. That's your number of favorable outcomes that they are. Not so? So how do I work out the probability? The probability is going to be a number of favorable outcomes, which is 3 times 20 squared times 9 cubed, over number of possible outcomes, which is 21 cubed times 9 cubed. Of course that cancels, which gives me an answer of 2 times 20 squared over 21 cubed. Is that correct? Huh? The answer is 400 over 3087. Okay. 400 over 3087. Let's take a calculator away here quickly. You guys can see behind it. Alright, any confusion here, people? Anybody that did the sum that is confused? You didn't do the sum. You did it. You got it right?
I did the whole exercise wrong.
But you know where you went wrong. Anybody else want to share the mistake? Where did they go wrong? No words. I'm alone in the class again today. One of those days. It's frustrating, no? Talking to people and people not really responding. Okay, number 3. C. Has at least 1 4. So, 1, 2, 3, 4, 5, 6. So the scenario is, I can have a 4 there, not so. 1, 2, 3, 4, 5, 6. That 4 is not, 4 is actually next to it. No? Four is actually there, or there, not so. 4 it could be 1, 2, 3, 4, 6. 1, 2, 3, 4, 5, 6. So that 4 can lie there or there and there, there and there, and there and there. Or can have a triple 4, not so. That must means at least 1 4. So, I think we did the sum like this yesterday. How many options do I have here? 21, not so. 21, 21, 21, 21, 21, 21, 21, 21, 21. Okay? And how many options do I have here? These are the number 4, no? So which means to say when there's a number 4, we have only 1 option. Okay? So that is 1. You're going to work out the probability here. Okay, because there's 1 number. How many options do I have here? eight, 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 eight options. But yesterday we discussed the complementary rule as well. Not so. This is the same as saying. It's exactly the same as saying one. The probability of at least 1 4. Least 1 4. The same as 1 minus the probability of no force. Not so. So that's a complementary rule. It always add up to 1. So that's simply going to be how many options? Do I have here? 21. Then 21, 21. There are 9 numbers to choose from. But if you're not going to consider the 4, how many options do I have here? 8, 8, and 8. Okay. So that will simply be 1 minus the probability, the favorable outcomes, which is 21 cubed, times 8 cubed, over number of possible outcomes, which is 21 cubed times 9 cubed. So that gives us an answer of 1 minus 21 cubed, cancel 21 cubed, so it's 8 cubed over 9 cubed. Which is 217 over 729. Is that correct? 217 over 729. Okay. Any confusion there, people? Otherwise, if you really wanted, you could have said 21 times. So this year, you could have just said for these 3 calculations. So your number of favorable outcomes would be there 3. 21 cubes times, there's 1 times 8 squared, no? Plus, this was 1 4. The next one is going to be 21 cubed, which is this category here. 21 cubed times there's 2 4s, which is one option, no? Times 8, and there's 3 of those. Okay, there's 3 of these as well. Plus 21 cubed times 1 cubed. You work that out. Okay? You just work out the answer. It's 21 cubed times 1 times 8 squared. Plus 21 cubed times 1 squared. Oh yeah, the 3 I'm forgetting here. Times by 3. 21 cubed times 1 squared times 8 times 3. Okay, plus 21 cubed times 1 cubed, which is 1. Going to give you 2, 009. 37, 637. So that is 2,09,657. So for your probabilities, number of favorable outcomes, which is 2,009,637, over number of possible outcomes, which is 21 cubed times 9 cubed. Times 9 cubed. So it should be the answer over 21 cubed times 9 cubed. 217 over 729. So if you can spot the complementary rule, won't it just be easier to do it that way? And the sum is worth 2 marks in you. Okay, so if you don't spot it, it's going to cost you a lot of work for that little marks, okay? Especially in paper 1 when you know many of those answers, or the graphs and the calculus and all of those things. We don't want to spend a lot of time on this. No? So if you spot the complementary rule, apply it. Will be good for you. Okay. Here's number 3. Let's look at number 4. Determine the probability of getting a 10-digit cell phone number, if the first digit is even. So it's 10, 1, 2, 3, 4, 5, 6, 7, 8. Now normally our first digit starts with a 0, no? But here this is doing it for calculation purposes. Okay. Determine the probability of getting a 10-digit cell phone number if the first digit is an even number. So how many options do I have here? 2, 4, 6, 8. So how many options do I have here? Could be 0 also. 0 or even. Okay, determine the probability of getting a 10-digit cell phone number if the first digit is even and none of the first 3 is 0. So you can't have 0 in the first 3. Because 0 is excluded. So how many options do I have? 2, 4, 6, 8. So it's 4 options. Not so. Then, none of the first 3 digits is 0. None of the digits may be repeated. So in other words, I have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is the, not 10. There are 10 digits. This is the possible outcomes, number of possible outcomes. Okay. So you use one even number. Okay. Then you use any of these even numbers. No, just say you take not 8. So how many options are we left with? 9. Not so. Now none of the digits may be repeated. So how many options do I have here? How many numbers can we choose from? 8. Why 8? Can't take 0. So it's 8. Then 7. So here I've used how many numbers now? 3 out of how many numbers? 10 numbers. There's no restriction on the rest of the numbers. Can you see that? So how many options can I choose from here? I've used 3 digits. Huh? So how can it be 6? 7. So here's no condition now that needs to be met here. Let's go again. The probability of getting a 10-digit number if the first digit is even. Okay? And the first 3 digits can't be 0. So you're excluding 0 from the first 3 numbers. So let's go. There's 1. So I can choose from 9 numbers. Not so. Right. You have chose 8 as the first number. This must be even. How many numbers is left? 8 numbers. Now I'm taking 0 out for the first 3 numbers. Okay? Then let's say you chose 5. Then how many options do you have then left for the next bit? 7. If you chose then for the third digit 3, but now for the rest we can consider 0 as 1. Can you see that? So how many numbers can we choose then from? 1, 2, 3, 4, 5, 6, 7. 7 numbers you can choose. That's why I put the 7 here. Can you see that? Then, how many options do I then have? 6. Then, 5, 4, 3, 2, 1. You see that, people? So, that's going to be 4 times 8 times 7 times 7 factorial. You all agree with that? Because that's 7, 6, 5, 4, 3, 2, 1. Okay, so the question was for the probability. So it's a number of favorable outcomes over a number of possible outcomes. So the number of favorable outcomes is 4 times 8 times 7 times 7 factorial over number of possible outcomes so that will be 10 bits 1, 2, 3, 4, 5, 6, 7, 10. Okay. So how many options do I have here? Remember, this that is given is a condition. Okay, or a favorable outcome they're looking for. So how many options do I have here? 10. Then? I would say 10 to the 10. Let's check what the answer is. 14 over?
45.
Okay, then they use 10 factorial. So it's 4 times 8 times 7 times 7 factorial. 14 over 45. Yeah, they use 10 factorial. Why? Because the numbers are not repeated, correct? So it's going to be 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, which gives you 10 factorial. That gives us an answer of 14 over 45. If I had said this question, I would have first said that the digits may not be repeated, and I would have given the condition. Okay. Then I would have known that the number of possible outcomes, the numbers are also not repeated. So I would have said, determine the probability, given that the digits may not be repeated. Wait. First digit is even, none of the first. Yeah. Then I would have said determine the given a 10-digit code, the digits may not be repeated, and then I would have said the condition. Okay? So that we know that the number of possible outcomes, I wouldn't have said 10 to the 10. You guys understand? But they started off with the condition, which is the number of possible outcomes. Okay? And then they went through all the way, and they said then the digits may not be repeated. Okay? So I would have first said the digits may not be repeated, and then the condition. Okay? So we wouldn't set the learner off from be confused. Because if I had given something like this, I think I would have had to give you the mark if you had said 10 to the 10 here as well. Okay, and that's not the answer they're looking for. You guys understand? So in the exam it will be more precise, more straight to the point, okay? We don't want to confuse you guys, okay? We're not in that business, okay? Although you feel like we always need to confuse you, no? Don't you guys feel like it? No, okay, nice. You're saying yes or no? No, okay. Okay. People, number 5. Consider the letters of the word winners. Now, we spoke about this word already. Didn't we do the sum? Huh? Different extra. Okay, it's a different scenario. So, but we're busy with probability. So, consider the letters of the word winners. The repeated letters are identical. So, what does that mean? What comes to mind? The formula. Yes, the formula. Alright, what's the formula? N factorial over M1 factorial times M2 factorial times and so on. Notice whenever I read the word, repeated letters are treated as identical, that's the thing I write down. Okay, because I know I'm going to use that formula somehow or other. So, let me the word winners. So, repeated letters are treated as identical. If the letters are arranged in any order without repetition, which means the words are not, the letters are not repeated. To form different words, what's the probability that the word form will be with a start with a W and end with an S? So you start with your number of possible outcomes. Number of possible outcomes. How many birds would I draw? So yeah, the formula, no? So it's going to be n factorial. So it's 7 factorial over. How many repeated letters are there? 2. The double n is repeated, not so? So it's 2 factorial. That's number of possible outcomes. If we're looking at number of favorable outcomes, it said start with the letter W. So it's 1, 2, 3, 4, 5, 6, 7. And end with an S. What am I left with? Inners, no? Inner, sorry. So how many options do I have on the first bit? 1. And on the last bit? 1. So in other words, it's 1 times. How many letters are here? 5. So it's 5 factorial over 2 factorial times 1. So it's simply 5 factorial over 2 factorial. So when we work out the probability, how do we calculate probability? Number of possible outcomes, favorable, sorry. Favorable outcomes over number of possible outcomes. Okay. So the number of favorable outcomes is 5 factorial over 2 factorial, which must be divided by 7 factorial over 2 factorial. Over. Do that in the calculator. 5 factorial over 2 factorial. So you repeat the letters. Divided by 7 factorial over 2 factorial. Gives you 1 over 42. Is that correct? Huh? 1 over 84. Right, I made a mistake somewhere. Let's check. Who got 1 over 42? You got 1 over 42. Okay. Who got the textbook's answer? Nobody. Let's just check. Did they give you the calculation in the book? And in the back, did they show you how to get that answer 1 over 84?
No, sir.
No. Don't have the answer. Let's check again. Answer the letters from the word winners. 7 factorial over 2 factorial. Start with the letter W and end with the letter S. 1, 2, 3, 4, 5. So it's 5 factorial over n is repeated, so it's 2 factorial. I can't see my mistake. What did I have? 1 over 84. One of the 2's they left out. Let me just check. Yeah. They left this one out here. Can you see? They didn't do when they did a calculation, they didn't add that to the. But why must this 2 be added? Because we are told that repeated letters are treated as identical. So that 2 must be in here. Can you see? Which they have omitted. So, since on the possible outcomes they left out the 2 factorial, the next answer is also going to be a factor of 2 in the denominator. You'll see now. Unless they just typed it in wrong. Okay. So let's just look at the other side of this. example for B. Okay. Then B, it says start with the letter N, so it's 1, 2, 3, 4, 5, 6, 7. You must start with the letter N. So how many options do I have here? 1. Times, how many letters are left? W, I, N, E, R, S. Which is how many letters? 6 letters. How many repeated letters are here? None. Not so? So that is just 6 factorial. So for your probability, it's going to be number of favorable outcomes, which is 6 factorial, over 7 factorial, over 2 factorial. So is your answer 1 over 7? Yes, they again left out the 2 factorial. Can you see that? Okay, but what you guys can do is speak to your friends, or ask the other maths teacher to work it out. And then you get back to me if I'm wrong. And we just have to correct and try and see how they actually did it. Okay? So I don't say I'm 100% correct, but I would stick with that 2 factorial. No? But speak to other people, and then if I'm wrong, please come back to me and just explain to me why the 2 factorial is left out. But at this stage I would stick with the fact that it must be 2. Okay? Just check if somebody actually corrected in the textbook. This textbook belonged to Sarah. She was really good at maths. So let's see if she got that from. This is chapter 10. Chapter 10, exercise 5. Number 5. One away. No, not corrected yet. We're not changed it. So. Okay. Let's then go to the next question. Only 17 minutes in Zoom. Or 37. Yeah, I thought only 17 minutes has passed. Right, number 6. Consider the letters of the word winning. The repeated letters are treated as identical. So what's the formula there? You're all mumbling. That would be the case of m1 over, sorry, n factorial over m1 factorial times m2 factorial and so on. Not so? You all agree with that, no? So that's n factorial over m1 factorial times m2 factorial and so on. Okay. If the letters are arranged in any way without repetitions, the letters may not be repeated to form different words. What's the probability that the word form will be? Start with a W and end with a G. So, the number of possible outcomes would be what? I have 1, 2, 3, 4, 5, 6, 7 letters. Okay, so that would be 7 factorial over the repeated letters. The I is repeated. How many I's are there? 2. So it's 2 factorial times 3 factorial. Okay. Number of favorable outcomes would be, again we have 7 letters, 1, 2, 3, 4, 5, 6, 7. Starts with a W and ends with a G. How many options do I have here? 1. And here? 1. What are we left with? I, N, N, I, N. No? Is that correct? So how many, it says 1 times. How many letters are here? 5. So it's 5 factorial over 3 factorial times 2 factorial, or 2 factorial times 3 factorial. So your probability is going to be the number of possible outcomes over number of favorable outcomes, which is now simply 7 factorial over 2 factorial times 3 factorial, which must be divided by, this is that line, 5 factorial over 3 factorial times 2 factorial. Okay? Now the other way around. This is actually the number of possible outcomes. What's wrong with me? A number of possible outcomes is going to be 5 factorial over 3 factorial times 2 factorial, which is divided by, which as I indicated was this line, 7 factorial over 3 factorial times 2 factorial. That should give an answer 1 over 42. Check if that's correct. One over 504. Repeat it. So they're again leaving this out here. Okay, let's check. 5 factorial over 3 factorial times 2 factorial divided by 7 factorial. 1 over 504. I hope I changed it here. This is number 7, huh? 6. Does that printed and then didn't make any changes there either. So what I do suggest is you speak to somebody. If the answer is wrong, then you just bring it to my attention, okay? Otherwise I can't see why would they leave that out? Because of the condition here is that the letters repetition to form different words. Okay, so the letters are identical. For identical letters, this is the formula for identical letters, not so? Yes, and I'll still say it. Okay. Let's look at B. So B would be 7, so 1, 2, 3, 4, 5, 6, 7. So it must start with the letter N. No? So how many options I have here? 1. What are we left with? W-I-N-I-N-G. So how many letters are here? 6. It's going to be 6 factorial over 2 factorial times 2 factorial. So your probability is going to be 6 factorial over 2 factorial times 2 factorial divided by the number of favorable possible outcomes. So 7 factorial over 2 factorial times 3 factorial. This answer would also be different to what they have. Okay? So it's going to be 6 factorial over 2 factorial times 2 factorial divided by 7 factorial over 2 factorial times 3 factorial. 3 over 7. And they have 1 over 28. They have left out this story here. No? Let's put over 0 factorial, which is 1. 1 over 28. Okay? Is number 6. Number 7. Consider the letters of the word mathematician. The repeated letters are identical. If the letters are arranged in any order without repetition to form different words, what's the probability that the word form will, in the first case, start with the letter, the same letter? So if you're looking at number of possible outcomes, will be, how many letters are here? 13. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 13 letters. No? So this, for this calculation, it will simply be 13 factorial over, how many repeated letters are here? There's 2 A's, 3 A's. There's 3 factorial times. The T is 2, so it's 2 factorial times. There are 2 M's, 2 factorial times. The 2 I's, 2 factorial. Anything else? No. So that's your number of possible outcomes. Okay? So if you're looking at your number of favorable outcomes, so that's a condition they want you to consider. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, and it's over 13. So they say start and end with the same letters. So if it start, let's go with start with the M. So it starts with the M and ends with the M. So what are we left with? How many letters are we left with? 11 factorial over, you have 2 M's, no? How many M's are there? 2. So it's going to be 3 factorial times 2 factorial times 2 factorial. Okay, let's see if it starts with an M. If it starts with, what is the next one? A. It starts with an A and ends with an A. How many A's are there? 3. Not so. So that is going to be 11 factorial over. So that is out. So it's 2 factorial times 2 factorial times 2 factorial. Then it could start with the letter I. How many I's are there? 2 I's. 2 I's. So that would be 11 factorial over. So that will be there at that point now. No? So it's going to be 3 factorial times 2 factorial times 2 factorial. Then you could start with the letter T. And end with T. So what will this calculation be? 11 factorial over 3 factorial. How many T's are there? 2. So that's the last one. 3 factorial times 2 factorial times 2 factorial. So that's your favorable outcomes. Okay? So I can work it out. Otherwise the sum is going to be fairly large and I'm going to work that out as well. So it's going to be 13 factorial over 3 factorial times 2 factorial times 2 factorial times 2 factorial. You could just multiply by 2 all the time. Eh? So 2 factorial is 2. So that answer is 129,000. 729. No, 129,729,600. This here will give us, this is 11 factorial over 3 factorial times 2 factorial times 2 factorial. And how many of those fractions are there? There's 1, 2, 3 of them. Not so. So I can just multiply that number by 3 since I'm adding it. Plus, you got 11 factorial over 2 factorial times 2 factorial times 2 factorial. That gives us 9,979,000. 9,979,200. So to calculate the probability is going to be the number of favorable outcomes, which is 9,979,200, over the number of possible outcomes, which is 129,729,600. So that would simply be answer over 129,729,600. 1 over 30. And what do they have? So again they're leaving this out here. Can you see that? You just check. So it's times 3 factorial times 2 times 2 times 2. Nope, too many. What do they have?
1 over 654.
1 over 600. Okay, let's look at the last one quickly. Number 7, B, ends with the letter N. If it ends with the letter N, so it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If it ends with the letter N, how many N's are there? 1 N. Huh? 1 N. So how many letters are we left with? 12, not so. 12 letters. How many repeated letters are there? 3 factorial times 2 factorial times 2 factorial times 2 factorial. Okay, so it's 2 M's, 2 A's, 3 A's, 2 T's. What was the other repeated letter? H. No. Right. Okay. Your probability. What's up, baby? Right over there. There's 12 over 30. What's the answer there? 1 over 624. Right, find out by Miss Dixon. If I'm wrong, we'll just have to just re-explain this, okay? Privilege, have a day. Good afternoon, class.